Hi, I'm Jamil, and today in this section we'll be looking at systems of equations. Our objectives will be to learn about linear systems, the substitution method, the elimination method, special systems, nonlinear systems, and applications of systems. We'll start off by looking at the graphical representation of a linear system. Here what we see is a linear system in two variables. Now, keep in mind that a linear system that only contains one linear equation would have an infinite number of solutions. But in this system, we see two linear equations, and the solution to this system would be the point of intersection. So in this case, we have one solution and one solution only, because the point of intersection is the point 0, -2. Now let's look at this particular picture. Here again we have a linear system in two variables, but in this case, since the two lines are parallel, they don't intersect at all. In a system such as this, we would say that there is no solution because there are no points of intersection for the two graphs. One more case to look at is the linear system in two variables with the two equations representing the same line. Here, since both equations are actually graphed as the same line, they have infinitely many solutions, since the two lines are actually placed one right on top of the other. A system such as this is said to be a dependent system. The first system we saw that had only one solution is said to be consistent and independent, and the second one that we saw, which had no solution, is said to be an inconsistent system. Let's go ahead and take a look at an example and use the substitution method to solve it. Here we're asked to solve the following system: 3x plus 2y equals 11, and the second equation is -x plus y equals 3. In order to do this, what we'll do is we'll use the substitution method. Now what that means is in one of these two equations, we'll solve for one of the variables and replace it in the other equation. Let me show you what I mean. Here in this equation, the second one, we have -x plus y equals 3. It's very easy to solve this equation for y by adding x to both sides. So what we'll do is we'll rewrite this equation, adding x to both sides, and it'll become y equals 3 plus x. Now that we know that y is equal to 3 plus x in this system of equations, we can take that information and substitute it back in for the y in the other equation. So rewriting the other equation, 3x plus 2 times, now instead of y we'll use 3 plus x, because that's what we know y is equal to, and then make it equal to 11. We now have an equation that has only one variable that we can solve. So writing this out, 3x plus, and now let's distribute the 2. So 3 times 2 is 6, plus 2 times x is 2x, and that equals 11. Combining like terms, 3x and 2x gives us 5x plus 6, and that equals 11. Subtracting 6 from both sides, we get that 5x equals 5, and then dividing both sides by 5, we find that x equals 1. So now that we know x equals 1, what we can do is go back and find the y value. In order to find the y value, we can substitute our value of x into either of our two original equations or the newly formed equation we found for the substitution. Since we're looking for the y value when x is equal to 1, I'll substitute back into the y equals 3 plus x equation that we found. So doing that, we get y equals 3 plus 1, and that equals 4. So our solution here is x equals 1, and y equals 4. So that's our point of intersection. Now one thing you should do to make sure that this works is go back and check those answers in your original equations. If I check 1, 4 in our two original equations, let's see what happens. Substituting 1, 4 into the first equation, we get 3 times 1 plus 2 times 4, and we want that to equal 11. So 3 times 1 is 3, 2 times 4 is 8, and sure enough 3 plus 8 does equal 11, so it checks out in the first equation. Now just taking a moment and checking in the second equation as well. -x would be the value, -1 in this case, and then plus y, well our value for y is 4, so it's -1 plus 4, and it should equal 3. And working that out, -1 plus 4 does in fact equal 3. So we've got the solution to the first set of equations. Another way to confirm our answer is to look at the graphing calculator and find the point of intersection. I've already graphed these two lines on the calculator, and sure enough we've confirmed that the intersection between our two lines is the point x equals 1 and y equals 4. Another method we can use to solve system of equations is the elimination method. By multiplying one equation by any non-zero element and then adding it to the other equation, we can somehow solve these systems. Let's take a look at an example that uses elimination. Here we're given solve the system by elimination. and the first equation is 4x plus 3y equals negative 1, and the second equation is 2x plus 5y equals 3. So what we want to do is we want to multiply either the first or the second equation by a non-zero number that will help us to eliminate one of the variables. So what you may have noticed is that the 4x and the 2x can be altered so that they will eliminate. What I'll do is I'll multiply the second equation by a negative 2, and by doing that, if we multiply this entire equation by negative 2, what we end up getting is negative 4x minus 10y equals negative 6. Now, using that in conjunction with the first equation, which is 4x plus 3y equals negative 1, we can now add these two equations together. By doing this, the negative 4x and the 4x cancel each other out, and then we're left with just the y as a variable. So negative 10y plus 3y is negative 7y, and then negative 6 plus negative 1 is negative 7. So solving this equation is fairly straightforward. We divide both sides by negative 7, and we end up with that y equals 1. Now, in order to find our value for x, what we need to do is take that value of y equals 1 and substitute it back into one of our original equations. So substituting y equals 1 back into the top equation, we have that 4x plus 3 times 1 should equal negative 1. So that's 4x plus 3 equals negative 1. Then subtracting 3 from both sides, we get 4x equals negative 4. And then finally, dividing both sides by 4, we get that x equals negative 1. So the answer for this particular problem is x equals negative 1 and y equals 1. Let's now use the elimination method to see how it would work on a dependent system of equations. Here we're asked to solve this following system: 3x minus 2y equals 4, and negative 6x plus 4y equals 7. What we'll do is we'll use the elimination method again and try to make it so that one of the variables will cancel out. So what you may notice is that we can turn this 3 into a negative 6 by multiplying the top equation by negative 2. So that's what we'll do. We'll take this whole equation and multiply it by negative 2. In doing so, I'll distribute that negative 2, and we'll get negative 2 times 3x, which is negative 6x. Negative 2 times negative 2 is positive 4y. And then negative 2 times positive 4 is negative 8. Now, what I need to do here is, because these coefficients match up exactly, I need to subtract the bottom equation from the top. So in order to subtract the bottom equation, what we'll do is we'll change all the signs. So this will become a positive 6, this will become a negative 4, and that will become a positive 8. And what we'll do now is add these two equations together. So doing that, the negative 6x and the positive 6x leave us with 0. But notice the positive 4y and the negative 4y combined also leave us with 0. So the left-hand side of this equation is 0. On the right-hand side of the equation, we have 7 plus 8, and that gives us 15. And that tells us that we've got a system where we find that 0 is equal to 15. Well, we know that this is false. So anytime a result like this happens, it means that this system has no solution. So this is an inconsistent system. Let's take a look at another example that uses elimination. Here we're asked to solve the following system by elimination: 4x minus y equals 9, and negative 8x plus 2y equals negative 18. In order to do this, we'll again use the elimination method. So what we'll do is we'll take the first equation, and we'll multiply it by 2. So multiplying that first equation by 2, what we end up with is the following. 2 times 4x is 8x. 2 times negative y is negative 2y. 2 times 9 gives us 18. And now, when we add these two together, we get negative 8x plus 8x, which gives us 0. Positive 2y minus 2y, which again gives us 0 on this side. But notice on the other side we have a negative 18 plus 18, which gives us 0 as well. Now 0 equals 0 tells us that we're dealing with a dependent system of equations. Now when we have a dependent system of equations, what that means is both lines are actually the same line, so they're graphed one on top of the other. This means that we have an infinite number of solutions. What we need to do now is solve one variable in terms of the other in order to find a way to write down some specific solutions. So again, here was our original system: negative 8x plus 2y equals negative 18, and 4x minus y equals 9. What we're going to do is we're going to take the second equation and solve that for x. By solving that for x, we'll add y to both sides, which gives us 4x equals 9 plus y. And then we'll divide both sides by 4, which gives us that x equals 9 plus y over 4. So now, here's how we'll write our solution set. The values of x can be given by y plus 9 divided by 4, and that's good for any value of y. So our solution set can be written as the following. Now remember, this represents an infinite number of values. So if we want to find some specific values, what we'd have to do is find specific values of y and substitute them in. For instance, if we wanted to know what the answer would be that had the y value 3, all we'd have to do is go back to our answer and set y equal to 3. In doing that, we'd end up with 3 plus 9 over 4 for the x value, and 3 for the y value. Then working that out, 3 plus 9 is 12. 12 divided by 4 is 3. So one specific answer would be the point 3, 3. We'll now go ahead and take a look at nonlinear system of equations. A nonlinear system is a system in at least which one of the equations is not linear. Let's look at the following example. Here we're asked to solve the system 3x squared minus 2y equals 5 and x plus 3y equals negative 4. Since this is nonlinear, we're going to go ahead and use the substitution method, and using the second equation, we're going to solve it for y. So, subtracting x from both sides, we'll end up with 3y equals negative 4 minus x, and then dividing both sides by 3, we get that y equals negative 4 minus x all over 3. Now taking this result and substituting it back into the other equation, in other words, replacing the y in the first equation with this, is going to give us this new equation, 3x squared minus 2 times negative 4 minus x all over 3, and that's going to equal 5. So from here, what we'll do next is we'll distribute the, we'll multiply everything by 3 to start with, so we'll eliminate this denominator. So in doing that, what we'll have is 3 times 3 is 9, so we have 9x squared minus 2 times the negative 4 minus x, and by multiplying by 3, all we've done here is eliminate that denominator of 3, and then that will equal 15. So from here, what we'll do now is take that equation, which we left off as 9x squared minus 2 times negative 4 minus x equals 15, and now we'll distribute the negative 2 across the parentheses, so we'll have 9x squared, and then negative 2 times negative 4 is a positive 8, negative 2 times negative x is a positive 2x, and it's equal to 15. And now, rearranging the terms and bringing the 15 over to the other side, we have 9x squared plus 2x, and then subtracting 15 from both sides gives us a negative 7. All of this equal to 0. And now factoring this, we end up with 9x minus 7 times x plus 1 equaling 0. And setting each factor equal to 0, we find that 9x minus 7 must equal 0, and x plus 1 must equal 0. So in this equation, that gives us that 9x equals 7, and then dividing by 9, x equals 7 over 9. And then over here, we subtract 1 from both sides, and we get that x equals negative 1. So the two values of x that we find to work are x equals negative 1 and x equals 7 over 9. But what we still need to do is go back and find the corresponding y value. So you may remember that the y value that we were looking for from the substitution equation was given by y equals negative 4 minus x all over 3. And keep in mind, we just found out that x was going to equal 7 over 9 and that x was going to equal negative 1. So substituting these values back in, what we end up with is y equals negative 4 minus, in this case, 7/9, all that divided by 3. And when you work that out, we find out that the y value is negative 43 over 27. And then doing the same thing for the x value of negative 1, we get y equals negative 4 minus the negative 1, all divided by 3. And that gives us that y equals negative 1. So our solution set for this particular system are the points 7/9, comma, negative 43 over 27, and the point negative 1, comma, negative 1. All right, now it's time for you to give this a try. take a look at this nonlinear system of equations and try to find the solutions. Solve the nonlinear system of equations analytically. Try to use the elimination method. Here you're given x squared plus 2y squared equals 9, and 3x squared minus 4y squared equals 27. Give this a try and check back with me when you've completed it. Okay, let's see how you've done. The first thing we're going to do is we're going to multiply that first equation by 2. So let's go back and multiply that equation by 2, and what happens is by multiplying this whole equation by 2, we end up with 2x squared plus 4y squared equals 18. Now, adding these two equations together, we have 3x squared plus 2x squared, which is 5x squared. The variable y eliminates nicely, so there are no y's left over. And then 27 plus 18 gives us 45, and we have 5x squared equals 45. Dividing both sides by 5, we get that x squared equals 9, and that tells us that x has to have the value of either negative 3 or positive 3. So now we know our values for x. Let's take these values and substitute them back into the first equation to find out what the y value should be. So going back to the first equation and using negative 3 for the x, that gives us negative 3 squared plus 2y squared equals 9. Well, negative 3 times negative 3 is 9, plus 2y squared equals 9. Subtracting 9 from both sides gives us 2y squared equals 0. Dividing both sides by 2, y squared equals 0. And then finally, solving for y, we find that y equals 0. So one of the points is negative 3, 0. To find the other, we go back and substitute in 3, but that's almost the exact same thing, because when we square the negative, it's going to act the same as squaring the positive. So we have 3 squared plus 2y squared equals 9, which gives us the very familiar 9 plus 2y squared equals 9. Subtracting 9 from both sides, we get 2y squared equals 0, and this leads again to y equals 0. So the other point that we're going to find is the point 3, 0. In this section, we've taken some time to look at systems of equations. You've learned about the elimination method and the substitution method, as well as linear and nonlinear systems. You should practice the exercises in your textbook to get better, and I'll see you next time.